All right, so our last topic this semester is Newton's method, which is used to approximate the square root of an integer. I would encourage you to Google Newton's method animation, maybe, to find something that shows you how when you apply Newton's method over and over again, it gets you a closer and closer approximation to the square root of n. Here, I'm just going to show you what the process is. Okay, so the idea is we're going to start with an initial estimate of the square root we're going to call S naught. And then for each step, we're going to try to get a better approximation of that square root. And so the sequence that we're going to use is that the next term in my sequence equals 1/2 times the previous term plus n over the previous term. All right, so let's see how that works. We want to find three estimates for the square root of 2, starting with an estimate of 1. So my first, or my 0th estimate is S naught equals 1. And so to find S1, I'm going to plug into this formula. So S1 is 1/2 times the previous term, S naught, plus n over S naught. So let's plug in what we know. S naught is given to us here, so I plugged in 1 for S naught, and we're looking at the square root of 2, so n is 2. All right, and then we multiply and add to get an answer of 3/2 or 1.5. All right, now this 3/2 is our S1, so when I go to find S2, I'm now going to put in S1 for my SK, right? That's the previous term. So I plug in 3/2 for S1 in each slot, and my n doesn't change. I'm still trying to approximate the square root of 2. All right, when you have 2, let me just make sure we're all confident about dealing with this. 2 divided by 3/2, I can think of as 2 over 1 divided by 3/2, and that's the same as 2 over 1 times the reciprocal 2/3, which is 4/3. Okay, so that's where that 4/3 there came from. You need to get common denominators here to add. I've not shown that, but we've done lots of examples with fractions. So at this point, you should be able to get a common denominator. And what you get is 17/12 for S2. All right, so we were asked for 3 estimates, so I need to go one more step. I'm going to solve for S3. So now I'm going to plug in S2 in each of these spots in my formula. Again, to simplify this fraction here, you're going to multiply by the reciprocal of the denominator, and then you've got to get a common denominator to add these two fractions. What I get is 577 over 408, which when I enter into my calculator gives me 1.414. Now, what is the square root of 2? Let me just pull up Desmos real quick. Square root of 2 is 1.414213. So you can see already, just going 3 steps, this is a pretty good approximation of the square root of 2. All right, so what are the real numbers? The real numbers is the union of the rational numbers together with the irrational numbers. In the real numbers, your number's decimal form is either terminating or repeating, in which case it belonged to the rational numbers, or non-repeating, in which case it's an irrational number. Every integer is a rational number and a real number. Every rational number is a real number, but not every real number is rational. So here's the picture that you want to have. These are the number systems that we've worked through all semester. So we started down here at the bottom in the natural numbers. Those are contained in the whole numbers. All we did was tack in 0. The whole numbers are contained in the integers. All we did was tack in the negatives of each of the natural numbers. And then the rational numbers were composed of ratios or fractions where the numerator and denominator came from the integers. Okay, the reals is the rationals together with the irrationals. All right, so this is just a summary of what we've done this semester.